All right, so we're about to go live here. Well, we should be live here on our second day. Today, we are doing algebra. Somebody say algebra. Algebra, bro. So that's what we're doing today. Tomorrow, well, we're doing these lives every day, midday. But tomorrow, I'll be late. I'll be a little later tomorrow because I have an important appointment lunchtime. So maybe around 2, maybe around 2 p.m. I will be jumping in tomorrow. So all right, so but don't forget to like. Midday every day we're doing this thing, well, except tomorrow. And today we're focusing on algebra. So let's just jump one time into it. Let's go, folks. Good to see you, Sanjaya. Good to see you, Jerome, Kasim. Everybody press like on the stream. Now that I'm live here, now that I am live here, YouTube should send it to more people. So more people should be coming in. All right, so I hope you can make the numbers we make yesterday, maybe at 200, 300. So let me see, let me know when you reach 200. If we reach 200, 2x minus 3 plus 3 over x is equal to 0. This topic is called algebraic fractions, And the key to this topic is being able to find the LCM of an algebraic expression. So in this case, what I want you to do every time you see this, and it's very popular in number 2, we do in algebra, is to just put the product of the two of them. So put 2x minus 3, put it in brackets and multiply it by the x. Then put a line like this. They call it a vinculum or vinculum or some kind of thing. So, and then this is the LCM thing like this. I'll remember this. Watch, like 2/3 plus 1/5, and then we get the LCM, which is like 3 by 5, 15. So 15, and then it'd be like 3 could go into 15 5 times, and then you say 5 by 2, 10. That's the same vibe we're doing. It is the same vibe, ladies and gentlemen. 5 into 15, 3. So you say 3 by 1 is 3. And they used to make all the write out all the working and thing for that back in the days. Now you don't need to write all the working for that. So tell me if you're going to follow what happened here. I say 2x minus 3 into the denominator. It will cancel with this, and the x will come out, and the x will have to go and multiply by the 2. All you agree? You agree? So it'll end up with 2, and you can think of the x coming here one time. And then similarly, you should end up with 3 by 2x minus 3. 2x minus 3. So why is in the chat if you understand that flow? That is very likely what's going to show up in your exam. You're going to see something like that in your exam. One of this is going to be in your question too. So now we have 2x plus 6x minus 9. If it's blurry, it's on you. And this is coming across crystal clear. So if it's blurry, you have to go on your YouTube setting and increase your visual setting from maybe some kind of low to higher quality. Right? 2x plus 6x. What did I do? Class? We start off kind of slow today, boy. I multiply the 3 by the individual terms in the bracket. That's called expansion or distribution. So verify that my numerator looking good day. And we're going in the denominator. What's going in the denominator? So in the denominator, it's 2x minus 3 and x is equal to 0. Now, because this is equal to 0, it means that the denominator is 0. For this to be equal to 0, the only thing that can happen is that the denominator is equal to 0. So that kind of eliminates the denominator from the situation. Thinking of another way I can do this. There's actually a faster way I'm seeing that I could have mash up this question. But anyhow, this is what's going to happen here. The denominator, I shouldn't say equal to 0. The denominator, when it multiplied across, will be eliminated by the 0. So like if I multiply the denominator by the 0, I would get, I would just end up with 2x plus 6, which is actually 8x minus 9 is equal to 0. So 8x is equal to 9, and x is equal to 9 over 8. How many of you all get that? 9 over 8. Tell me if you understand that, if it's making sense. What's the next way we could do this by? What is another way we could get this done? Well, instead of using that LCM technique, which you have to know anyway, you had to know that LCM technique anyhow. But if you want to not use the LCM technique, you could use the famous cross multiply technique. It's a kind of cross multiplying thing. Tell me if you've seen this other way we could solve this question. What we could do is bring across this term. Think of it as a term and we bring it across. So can you see that this will be 2 over 2x minus 3. When you bring it across, you get negative 3 over x. Then we do that kind of cross multiplying way by Darwin, by Levi, by Kai, by. We're going to do that kind of cross multiplying. So the 2 will multiply by the x and the 3 will multiply by that. Watch it. So you're going to get 2 by x and the 3, let's have the 3 take the negative sign. So this is going to be negative 3 by 2x minus 3. And we can, well, sorry, x by 2 is 2x, right? So we kind of boil down to the answer there already because you'll end up with 2x is equal to negative 3 by 2x is 6x. And negative 3 by negative 3 is plus 9. And when I bring across the 6x, what happens? It's actually negative 6x because negative 3 by 2x is negative 6. When I bring across the 6x, right, Tamara? If I bring across the 6x, we could just pin Christy comment on the screen because Christy can help you people who screen blurry. You'll get 2x plus 6x is equal to 9. So that's 8x equal to 9. And then it's this x is equal to 9 over 8. So this way you didn't have to think about the LCM. And I think this is an easier method if you're not no superstar in mathematics or anything like that. You just bring across this and you cross multiply and then you distribute and you move forward with your life. So that's the answer here. The answer is that x is going to be equal to 9 over 8. I want to clear up the space to do the working for the next one. Because we need to factorize. And in CXC, you will be asked to factorize either difference of two squares, quadratic equations, basic factorization, or grouping, factorization and grouping. That's why they bring the 4 terms. So from this, I could see this is just a basic factorization. It have the r squared here, yes, which kind of hinting towards a quadratic equation, but then it has an additional variable. There's an additional variable t. So what are t doing there? You see that t? So it's not really a quadratic because it have 2 variables. That's not constant. That's messing us up. So you just need to find the like terms here and then hope for the best. So for part 1, we'll have 4rt minus 2r squared. What's common? What's common? What's common? So the questions with factorization, when you have basic factorization, what is common? What is missing? 2 questions asked. What is common? Just 2 and r. 2 and r. So I can extract the 2 and the r. So I'll put equal, put the 2 and the r here. And then in the brackets, I want to put back what is missing from the individual terms. So what is missing? A 2, because I'll need the 2 by this 2 to create the 4. So 2 and a t, because there was not t here. So 2t, that's good. And this one already has the 2, so I don't need to put the 2, but it's missing an r. R by r is r squared. And just like that, Jason, well done, Jason, well done. Jason again. And Shimar. Yeah, man, people getting this thing up, people getting this thing up. What about the next one? 9m squared minus n to the power of 4. So this could be a difference of two squares because we see and the reason I know I can do basic factorization here, there's nothing really common here. And there's a square here, there's a to the power of 4 here, but don't worry, that is just like n squared by n squared. So well, this is 9m squared. 9 is a square number. So it's strong indication that I have to do difference of two square terms. So I need to find the individual square root of each of the term like this. This is one of the techniques we show how to do this difference of two squares. So we say the square root of 9m squared. The square root of 9 is 3, and the square root of m squared is m. 3m multiplied by 3m will give me back 9m squared. And what's the square root of n to the power of 4? The square root of n to the power of 4 is actually n squared. And we did some indices yesterday. I think we do some indices. N squared by n squared is n to the power of 4. So if I get the square root of n to the power of 4, it means it's n squared. Making sense? So now that I have the square root of both terms in the difference of two squares, I can finish off strong and say, therefore, hit them a little therefore, 9m squared minus n to the power of 4 is equal to these two terms. I want to put them in a kind of binomial situation like this. 3m minus n squared multiplied by, I'm running out of space here, boy. Oh, Jesus. Jesus and ages. All right, let me see. Pull this back a little bit. Just making a little space here. All right, so now we have 3m plus n squared. Yeah, we good there. So what do you think? You can do them question? I kind of taking my time and explaining each one, and I'm going super fast. We'll see how much of this we can get done today. I have a kind of deadline here because the engineer going to be some 100 feet in the air. So, all right, the last one. What's the last one? The last one is clearly a quadratic. Clearly, that's a quadratic. It's using a though instead of x. And with quadratics, we use the AC method, where we say we want two numbers that will multiply, and you can look up my video on this on YouTube. Two numbers that will multiply to give us a by c. So 3 by -3 is -9. But the numbers should also add to give us -8. And so immediately I begin thinking of the factors of -9. 3 by -3 is -9. The factors are 3 by 3 or 9 by 1. And I need to get an arrangement that will give me -8. So an arrangement that will give me -8 is -9 and 1. Seen it? It takes a lot of skill to initially to get the hang of quadratics. And then when you have it, you're unstoppable. So that's the intermediate line there. And then you factorize 3a. I don't want to take my time and explain this quadratic thing. If you're struggling with quadratic, please watch my videos on quadratics. It will help you from 0. If you need to take it from 0, you watch it and you'll understand. I think it's my most watched video on YouTube actually. So what happening here, once you factorize, you take that and you put it back there one time, and then you just join this 3a plus 1 and a minus 3. How are we looking? 3 plus 1, a minus 3. You have to get a long time to Mara, J, Sean, all of them cooking it around Kogia. So we just knock off 1 mark, 2 marks. Why this thing moving by? I never tell you to move. And 3 marks from before here too. 3 marks for that? What is this boy? Or how did the first sample where this is 12 marks? It's not 12 marks these days, eh? So be careful of that. 9 marks. 9 marks for the entire question. These question twos will be out of 9 marks. So what is this called? This topic here is called binary operators, bro. Binary operators. Did you know that topic? And that topic is just basically fancy substitution. Yeah, so I bust my lips, so it's kind of hard to talk right now, but the math must go on. So binary operators. How do we do binary operators? I'm telling you, it's just fancy substitution, but don't let them hot up your head. So let me pull back in on page 2. Let me go go to page 2 now and just pull this binary operators part. And let me just knock this off. So hit them the lines there. So you see in the binary operation here, as I said, it's simply some kind of fancy, it's simply fancy substitution. You see it on page 2 there? All right, so fancy substitution. So we have A star B equal 4A B minus B squared. Hold on, I not seen the lines on my screen, but I realize, yeah, there it is, there it is. A star B is equal to 4AB minus B squared. And now they want us to find the value of 2 star 3. So stay with me, Alia, stay with me. Stay with me. So A star B is equal to 4. It's kind of telling you what to do with, this is, the 2 is in the position of the A, and the 3 is in the position of the B. So it's telling you who to substitute. So in other words, watch this next line I'm going to put here. This next line might explain what happened. 2 star 3 is really 4 by 2. Instead of putting A as substitute, binary operators is fancy substitution. And I like how they ask this question because they bring this every now and then. The next part now, watch the next part, Dave, for those of you who figure it out already. You all understand the substitution. Why is it each had to catch the substitution? So I replace all the A's with 2. It was only 1 A. And I replace all the B's with 3 according to the information given here. And now I just work it out now. And what you're getting 15. So let me try and make sure I get 15. 4 by 6 is 24. 24 minus 9 is hopefully 15. So 15 is the answer, and you get 2 marks for that. And usually you do get 2 marks for these fancy substitution binary operators. I find that's fantastic. And then the next part is something that asks every now and then, and I want you to learn how to do this. You see how they're bringing this word commutative? You all know the 3 operative laws, the 3 main operative laws: associative law, commutative law, distributive law. This is how they bring in the commutative law. And the commutative law is an operation that can do this is commutative. If it could do that. So the commutative law is saying that if you could change it around, it's commutative. So the fastest way to justify this in the exam, they could actually do a whole proof, which is not what they will be testing you on. The fastest way to justify this is to switch it around. So let me hit them the switch around and see what will happen now. If I say 3 star 2, now the A is 3. Instead of the A being 2 like before, the A is 3 and the B is the 2. So I'm switching it around to see if I'll get the same 15, because if I get the same 15, it means it's commutative. And I won't. Most of the times you don't. So 3, 2 minus 2 squared. And how much you get with this? How much y'all get with this? 4 by 3 is 12 by 2 is 24, but this time I'm subtracting just 4. I'm getting 20. Right? So 2 star 3 is equal to 15, but 3 star 2 is equal to 20. Therefore, this is not commutative. So it's easy to prove if something is not commutative if you could find a case that shows that it's not commutative. By showing that, yo, I used 2 and 3 and I switched it around and it didn't work out, you prove it. Understand how to do that because it could save you. They normally put this for 2 marks now. It will keep you, it will hold on at 2 marks for you in the exam. Let me do our next question. How much of these algebra questions all you want to do, boy? Let me hit them. My next one. Factorize each of the following expressions completely. So more factorization at the start of algebra. On page 4 here. 16m plus 4m squared. So what is looking like? What type of factorization y'all think we're going to do for this? Don't tell me my battery die here. For this one. What type of factorization? Basic. What about this one? What type of factorization you're feeling here? And then we need to solve. Then we need to do a transposition. So this is linear equations. I'm giving you all the topic every time. So linear equations, then transposition or subject of the formula, then inequalities with a number line, which has been very popular these few years. So there you go. This first one, the first one is basic factorization. Why? Because all I'm seeing the m squared, all I'm seeing square numbers, I am seeing an n. What I n doing it, I'm messing it up. It have two variables. So I could only start off with basic factorization, and maybe sometimes there's a nested something inside there. So let's see what happens for part one. I'm writing part one here, and then I'm gonna pull out what is common. I ask myself what is common. That's the first question. I'm seeing 4 can come out of both of these terms, and in terms of letters, an m could come out. And now I'm gonna put back what is missing for the individual terms. I'm seeing 4 is missing, because 4m by 4 is 16m, right? And then what is missing for the next term? We already have the 4, but we're missing one of the m's and the n. And that's it. Basic factorization, you're done. 1 mark. An indication of basic factorization to it will always be 1 mark, unless it's like a really long, kind of expansive thing. How was that? Y'all understand everything so far? How are we going? So part 2, this is clearly a quadratic. It's even written in the quadratic format. So once again, we're going to use the popular AC method. 4 by 5, 4 by 5, or 4 by negative 5 to be exact, is negative 20. So 2 numbers that will add to give me 19, but multiply to give me negative 20. Now, when the number is really close to the number that I want to get, 4 by 5 is 20, 19 is really close. I usually know it has to be the number plus 1, or number and 1. And in this case, I want the 20 to be positive so that the number here would be positive, right? Revise your quadratics if you don't know what's happening here. So I'm going to put 20x minus 5. And then I'm going to do some, this is factorizing 4 terms, aka grouping 4x into x plus 5. So I'm going to put x plus 5 here, I'll put it back 1 time. And to make this possible, what I'll do is just put a negative 1 here. Negative 1 by this would create back that, right? Group up 4x minus 1 equal x plus 5. That's how it works. And we weren't asked to solve. So we just factorize, and I'm seeing a whole bunch of people. Hey, we reached 300 by a whole bunch of people on this. So big up yourself. Part B now. So that's part A. Let me see if I can squeeze in part B right there. Make who the subject of the formula? Make B the subject of the formula. So A is equal to half A plus B H. We want to make who? B the subject of the formula. So you want to get across everything that is not B onto one side. So H is not B. Let me get, what's the first thing to get across? The half and the H could take a hike. So if I multiply everything by 2 then, if I multiply everything by 2, I'll have 2A and the half will disappear. So I'm doing it step by step. I could do this way faster, right? But I want to make sure you follow everything. Or y'all could think of it like I bring across these 2. 2 is dividing and I bring it across. Or I multiply everything by 2. However you want to think of it, I just get rid of this half and bring it onto the next side. If it was on division on that side, when it come across it into multiplication, then I'm going to bring across the H. So I have 2A over H because it's the B I want by himself. I couldn't bring across the A yet because the A trapped inside the parentheses, inside the brackets. So I couldn't touch that A. So 2A over H, and we have A plus B. And since it's just A plus B on that side, it's fair for me to just drop the brackets there now. So now what's left to do? Just to bring across Oh, I forget to do part B. All right, thanks, people. I'll swing back for part B just now. So just bring across the B. I'll put the answer for C. Let's put the answer for C. Or maybe we had to tell C to wait for we there, see we coming back. Wait for we there by C by. I'm gonna go and do B. Nah. We finish C now. The indecisiveness by So we want to make B the subject of the formula. So 2A over H minus A is equal to B. I could write it this way for those of you who like it this way. 2A over H minus B. We can make a attack back. Yeah, boy, we can make a swing back. So 2A over H minus B, and we good to go. If you can't transpose in mathematics, you will have a very bad time in the exam because it's not only going to come just straight up where they'll ask you to transpose. There's so much formulas where you'll have a missing thing and you need to find it and you need to rearrange the equation. How much time will you rearrange an equation in mathematics? Must be 1,000 times since you start secondary school, right? So you must know how to do that. So let me go and do the part B that we leave out, and then we can do part D, and then you can tell me if you all want to do our next question. I do this on page 5. All right, so part B is to solve a linear equation. So what we'll do is 5 minus 2 into x minus 1 is equal to 4 into 3 minus x. We have some distribution to do here. So it's going to be 5 negative 2x. And watch a common mistake here. When you have a negative sign with the number outside the bracket and you need to multiply by the negative 1, keep that in mind, and 2 negatives make a positive. 2 will be there. And this one is 4 by 3 is 12. And then 4 by negative x is negative 4x. Why is any chat following me? Are you seeing it? Rearranging like we do in interior design. Sanjay, how is the word? All right, so what we really want to do when we solving is bring all the x's on one side, bring all the numbers on one side. Bring all the x's on one side, bring all the numbers on one side. So we have negative 2x and negative 4x. Let's bring them to meet each other. And at the same time, one time I will bring across the 5 and bring across the 2. All we need to record is that if you bring it across, you're going to switch the operation. So the negative 2x stay in here. But coming to meet him is the negative 4x. But because it was negative there, it will switch to positive. And then the 5 and the 2 are positive. Don't think the 5 negative, the 5 is positive. That negative sign belongs to the term that comes after it. So it's really 12 minus 2 and then minus 5 again. So negative 2x plus 4x is 2x. And 12 minus 7 in all is 5. So at the end of the day, x is equal to 5 divided by 2. And that's the answer right there. You don't need to change it to decimal. 5 over 2 is good enough. So that is 2 marks. Why isn't each other fully understand? So thank you for getting my brother into Fatima. Big up your brother, big up yourself. And you're welcome. So let me just finish off strong with this inequality. We need to solve the inequality. As soon as I see an inequality, I think about the most important thing to think about with inequalities in this question. The trap cards, I call it. If you swap both sides, or if you multiply or divide by a negative number, you have to flip the inequality sign. Otherwise, you're going to get it wrong, my friend. So let me see if we're going to activate any trap cards. 3x minus 14. Other than that, you're just working normal. So that's how we start off. And now we want to work it out. So you're going to bring across the negative 14. That's not activating a trap card. We're just bringing across numbers. It will change to positive 14. So you get is greater than 5. 3x is greater than 15. Sorry, why did I say 5? And then x is greater than 15 divided by 3. So x is greater than or equal to 5. So now represent your answer on the number line shown below. What kind of weird number line is this? Because I'm supposed to say x is greater than or equal to 5, add 5 quite here. And what you're really supposed to do is draw a circle on the 5. And since, if it was just x is greater than 5, you'd leave the circle like that. But since it's say greater than or equal to 5, you need to shade in the circle, right? And then you need to point in the direction this way. And that's how you collect your mark. Make sure you know how to do that. Another one. Yeah, man, let me do our next one. Let me do another one. On page 6, we have a next question here lined up. What type of factorization? So the chances of you seeing a factorization, very high. And make sure you know how to do all of them. So this looking like 4 terms. From the time you see 4 terms, think about grouping. Most likely it is. We have a difference of 2 squares here because 1 is a squared number, 9 is a squared number, a squared. And there's no extra term, it's just a. So that is definitely difference of 2 squared, grouping. Then we need to solve some linear equations. Hold up, solve a linear, then solve a quadratic. Then we need to do what? A substitution, and a transposition. Classic. We done starting to see repeated ideas already, and I love that. So let me go. Let me see if I could fit all the answers in one page. Let me conserve the real estate here. So 9a squared minus 1. So there are a few ways to write out your answers for what is called this thing? Difference of two squares. Right now we're working with this kind of technique where we get the square root of each of the term. So that's 3a. And then the square root of 1 is 1. Not the negative one, the negative sign, just humble it right now. And then you write, therefore, 9a squared minus 1 is equal to the square root of them, 3a minus 1, and then 3a plus 1. So if you want, you can look up a video I have on factorization where I show how to do the 4 types of factorization, and you can get really good at it and just secure the bag. You know, this is like 4 marks coming with that all the time. And fs minus qr minus fr plus qs. Fs minus qr minus fr plus qs. Well, this is 4 terms thing, right? So normally you're supposed to pull out something common here, but there's nothing common there. But I see an f over here. If I bring this here and then I bring the q there, I might get lucky. So let me just rearrange before. Y'all understand what I'm going to do? I'm going to rearrange to see if I could get a little better setup here. Fs, I bring in negative fr there. Negative qr could go there. I just swap the 2 terms there. I don't need to change the signs. I didn't bring anything across the equal sign. It goes with its sign, right? Plus qs. And now, what is common? When you're doing this 4 terms grouping thing, you have to imagine an invisible line here, so between the 4 terms. And f is common, so I'll take out the f there. And then s minus r will sit down there good. And I seeing q is common here, but it was s minus r. So what you are going to do here? Tell me if you all seen it. Because I want to put back the same s minus r there now. That's how these grouping things work. Some of the brilliant people seen it already. What I will do is just rearrange these 2. So think of it like I just rearranging it up there so you could follow even faster. Qs minus qr. But when you see minus qr, this negative could stay with the r now. So I could pull out the q. Seen it? Pull out the q and have an s minus r there. And since both of them have s minus r in the brackets, I have f times this and q times this, I could say it's really f plus q times that. So f plus q will go in brackets, and then one of the s minus r goes there. And that's how you do this. So make sure you understand that, folks. This is a nice little twist they put on it. It wasn't that straightforward, right? We're still in like the mid to lower levels of what could come in the CSEC Maths exam, but make sure you understand and you can collect these easy marks. Part B, what we're trying to do is put the whole answer on one sheet of paper. It might work. It might work. Solve each of the following equations. 5 over 3 by x is equal to negative 10. KFC, nothing, nice food. And this is fantastically easy to solve. We're just going to bring across the 3. So 5 by x is equal to negative 10 by 3 is negative 30. Then we bring across the 5. Negative 30 over 5. You understand? Swap the operation. So x is just straight up negative 6. And forget about trying to make this fit in one page. Let me just go into the explanation. Hey, I need to insert a page. Hold on, because the next page is our next question, and these questions pre-lined up. I do all right, I insert a page, the new 7 now they by. And now what I want to do, I want to bring back up this last piece. Anybody know what this formula is? Anybody doing physics and you know what this formula is called? this formula. I know we still have to do this one. I'm not going to skip a question again, hopefully. But you know what this formula is called? I'll revise in all the physics. They kind of give you a hint here. So, we need to solve a quadratic. How much quadratic we going to solve? Boy? Imagine going into a maths exam and not knowing how to solve a quadratic. I feel ya. One of the things I tell parents this all the time, and if I ever talk to a parent or interview you, what I will do is ask it to solve a quadratic. If they can solve the quadratic, I know they're at a certain level in maths. If they can't solve it, I know, well, you ain't even reach half mark in mathematics yet. So 3 by 6 is, just don't give me a little time. 18, and I want two numbers that would add up to make 7. So already seen that 9 and 2 kind of going to play off there. I'll make the 9 positive. So it'll be 3x squared plus 9x minus 2x minus 6 is equal to 0. Then I'll say 3x into x plus 3. Put back the x plus 3 one time, and I see that little negative 2 could go there. Really nice. I kind of speeding through this one. 3x minus 2, x plus 3. Were we supposed to solve this? Yes, we were. And either if two multipliers, 2 factors giving you 0, one of them has to be 0. And this is coincidentally called the root. So anytime you have 2 numbers that multiply to give you 0, one of them has to be equal to 0. So either the 3x minus 2 is equal to 0, or the x plus 3 is equal to 0. So 3x is equal to 2, x is equal to 2 over 3. I just solved that for x. Or x is equal to negative 3. And that's my 2 answers there, which I'll get a long time. And yeah, this is the lens formula. Well done, Amila, and everybody else who say lens formula, Marissa and thing. The lens formula. So what I want us to do, given u is 2, given v is 3, find f. So let me rewrite it as 1 over f is equal to 1 over u, that the object distance, plus 1 over v, the image distance. I hope all your physics class, I have physics later, I tell you. Don't feel we still have class, we still have class. So 1 over f is equal to 1 over u, in this case 2. So when u equal 2 and v equal 3, we're going to get this situation taking place here. Plus 1 over 3. A half plus a third is how much? So what I can do is say the LCM. I can say the LCM of 2 and 3 is 6. 2 by 3 is 6. And 2 into 6, 3. 3 plus 3 into 6, 2. So a half plus a third is 5, 6. 5, 6. Yes. So 1 over f is equal to 5 over 6. But the answer doesn't want you to find what is 1 over f. It wants us to find what is f. So therefore, f, why did I write 5? Anybody write 5 when you're trying to write f? 5 at f is equal to 6 over 5. F is equal to 6 over 5. So if I flip the 1 over f, I'll have to flip the 5 over 6. And that we did. Last one is to make u the subject of the formula. Make u the subject of the formula. So we have 1 over f is equal to 1 over u plus 1 over v. Where is u? There it is. Wait, no, there it is. So we want to make u the subject of the formula. So let's get everything that's not u on one side. So 1 over f will be here. Take away 1 over v is equal to 1 over u. All you follow that? I just take that whole 1 over v term and say go so. And it switched the operation. So instead of being plus 1 over v, it's negative 1 over v. And now I need to reciprocate this, but I could reciprocate something if both sides have a solid fraction. It's hard for me to reciprocate this if this is not one term. So I actually need to make this one term first. Those of y'all who flip this and just flip these 2 things separately, that's wrong. Wrong. Don't do that. You have to make this into one term. So this is going to be FV. F into FV is V. V into FV is F. Don't forget the negative sign. And now I reach here. No is when you could reciprocate it and be like, well, if I flip this, I need to flip that, and that's the answer there. So I'll get U is equal to FV over V minus F, ladies and gentlemen. What do you think? You all understand? Mash up. Mash up. We have space for one more. When you're about again. Huh? Ah, yeah, we are real time, man. We have space for one more. We have space for one more. Two more. One more. Wait now. This is the fifth question already. That is performance. One more. So, are you ready for the algebra question? Is things just like this going to come? This based off of like the last 5 set of exams. So, if you find this was tremendously easy, you're in a good place. Go and do the last 5 years of algebra. Is coming question 2, and you're starting to look good. You're starting to look good, ladies and gentlemen. So let's just do this last one. W is equal to 3y over 2. I don't even know what the question is saying. I just start writing one time. I'm like a teacher. W is equal to make P the subject of the formula. So you need to make P the subject of the formula. P by itself. All right. So anything that is not P, you get it out. Now we can't go and bring across the 5 one time and the 5 trapped in the brackets. You have to is like when you start a job, the last person to get hired is the first person to get fired if anybody had to get fired. So the last operation, the thing furthest away in terms of operation from the P need to come across first. That's this term, 3y over 2. Or like you can do it separately. You can take the 2 and then you can take the 3y. Let me do it separately so everybody could follow along. So I'll bring across the 2. And I'll end up with 2 by W is equal to 3y P plus 5 into P plus 5. You all understand that? Because the 2 was dividing, bring it across and multiply. Then the 3y is multiplying. So when I bring it across, are you agreeing with me that I should have something looking like 3y here is equal to, and I have the P plus 5 there. And now it's just to finish strong enough. Joshua and them done mash it up already. So to finish off strong, the P would be P, I'll just bring across the 5 and it'll be negative. I'll swap in the sides one time. I hope you're okay with that. And that is we ready? Ramco gas. Solve the following equation by factorizing another factorization because they must bring a factorization in question 2. Otherwise, it's not CXC. A factorization doesn't come like 1 in every 10 times. It must have a little factorization. So who is this boy? This one looking highly suspicious. I'm detecting a piece of foul play. So, looking like I have a difference of 2 squares liming in this. Because the way to factorize and solve. So I could do it, I could take out the 2 and I'll see the difference of 2 squares. But I want to pretend like I wasn't seeing the difference of 2 squares. Let me see if I take out, I factorize it fully, what would happen. If I took out the 2 and m squared, I will end up with 9 minus m squared. Agreed? I'm watching this term here. Let me write it. Let me write it on top. Let me do it part right. We're on the last question. I could roll it, man. I could roll it, man. I could do this thought exercise with me. So is 2m squared could come out. That's the most things that could come out, the most amount of common things. So I'll end up with just 9 here minus and just m squared there. So at the end of the day, this is going to give me 2m squared into 3 minus m into 3 plus m. Those of y'all who understand that, fantastic. Those who don't, this is difference of 2 squares here, you know. 9 is a square number, the square root of 9 is 3. M squared is a square number, the square root of that is m. And then I have a product. It has 3 factors. So it's either 2m squared is equal to 0, which would just mean m is equal to 0. Bring across the 2, divide 0. 0 divided by 2 is 0. And square root of 0, 0. So, or 3 minus m is equal to 0. So negative m is equal to negative 3. So m is equal to 3. Or 3 plus m is equal to 0. So just m is equal to negative 3. So m could either be equal to 0, 3, or negative 3 if I do it that way. Let's try the other way that we can do this. 8 mash it up. Is that 1? I mean, that way it's come out. I hope I didn't make any mistake anyway. Nice. Or what is this? 18m squared minus 2. So we're going to the next page. 18m squared minus 2. I'm gonna just wait for the lines. 2m to the power of 4 equals 0. Okay, okay. I can just be a little more, what is the word I'm looking for? Conservative with the things that I'm taking out. So I can kind of partially factorize this. Maybe I can just take out 2. Maybe I can just take out 2 and humble myself. So if I want to just take out 2, I'll end up with 9m squared minus m to the power of 4. And then I do the difference of 2 squares. So I'll end up with 2 into, and the difference of 2 squares here will give me 3m minus m squared, and then 3m plus m squared, which means I can still factorize out a m. So yeah, all of them have an m inside them. So it's best if I actually take out an m. I have to take out an m. Otherwise, when I'm solving this, I will end up with the next question. This will just be too problematic. I'll end up with, I can solve this, you know. I'll end up with a lot of factors. I'll end up with 2 into m by 3 minus m, and then another m here into m, 3 plus m. And I'll end up back in the same place that I end up with before, equals 0, which is, hope you're all following, and again confused, which is the same thing here. So this one was a little challenging if you not accustomed to polynomials that go above the power of 2. But this is the idea behind it. Sometimes you do, what you want to take away from it is sometimes you do a basic factorization, because I just took out the common term here, which was 2m squared, and I end up with another thing. Like maybe I'll end up with a quadratic inside or difference of 2 squares. So I do that separately. I can show my working for this on the side too if I want, and do that separately. And then all 3 of the factors equal to 0. These 3 terms equal to 0. So either this one is 0, this one is 0, or this one is 0. And you solve all of them and you get some working for this. So let's finish off strong with the last part of this. Oh no, there is a question after this. Are you ready to do a question after? 375 people here. How much likes it have on this video? Are you pressing like and thing? Take a screenshot, put it on Instagram, tag me. Let me have something to repost when the live finish now. So let's do the last part of the question. You could add sticky notes and thing. I want to do it on page 9. And the last part of this question had some triangle talk and all kind of thing, right? Some triangle talk. John wishes to draw a triangle. Are we reading that? We seen it? He wishes to draw a triangle whose base is 4 times its height. So the base of the triangle is 4 times the height of the triangle. Given that the area of the triangle is 32 meters squared, determine the height of the triangle. Let me visualize this. So there's the triangle here, boy. That kind of long triangle. The base is 4 times the height. So let me say this is the height. I could write base here, but it's better for me to write 4 heights here. You understand what I'm doing there? You understand that? So the triangle is h high and 4h base. and the area is 32. So this is where they tie algebra into geometry, into measurement. So they give you something and you need to generate an equation out of that. What was the area of a triangle? Area of a triangle is base, the simple one, base by height divided by 2. But the base is 4 times the height. So the area of this triangle, in this case, let me write in this case here, make it look official. In this case, Your Honor, the area is actually 4 times the height by the 2, because the base is really 4 times the height. And a 2 will cancel here one time, 2, 2. So it's really 2/8 squared. I get nice and neat and compact there. So the area is really 2/8 squared, which means, therefore, since the area is really 32, 2/8 squared is 32. And 8 squared is 32 divided by 2, which is 16. And the square root of 16 is 4. It can't be -4. It is square root of 16 could be -4, but we can't use -4 in this case because you ever see a triangle with a negative dimension. So h is 4. Determine the height of the triangle. It's 4 meters. And if they say determine the base, 4 by h, 4 4s are 16. Last part, that was a nice question. Circumference C of a circle is directly proportional to its diameter. So C is directly proportional to the diameter. Represent this information as an equation in terms of C and D and an appropriate constant pi. All right now. So the circumference of a circle is pi d. I don't know what it was trying to be here. But anyhow, so now we have, you understand how we use the pi as a constant, but this is actually an equation that you know from since primary school. The incomplete table below shows corresponding values of C and D. Use the equations obtained in there. Using that equation, where pi is 22 and 7, so they want you to use pi as 22 and 7, find the values of x and y. So in other words, they're saying, take some free marks now, boy. Take some free marks. So in this case, in the first case, where we want to figure out x, I would say, therefore, x is equal to pi times d, and d in this case is 7. And since pi is 22 over 7 by 7, it's equal to 22. Free marks. And in the case of y, 44, because 44 is C, so 44 is equal to pi by y, because y is in the place of d, pi by d. So you understand it's a substitution question with a little bit of variation, but it didn't really go deep into the variation technique. But pi is really 22 over 7. Why? So anybody can multiply 44 by 7 and tell me how much I'll get, why? Well, the best thing to do might be to divide by 22 first. So 44 divided by 22 is 217 y, and then 7. So y is equal to 14. At the end of the day, you could go and check it out and make sure. You bring across the 7, divide by 22, 2 by 7. Yeah, by y is 14. Hey, let me put some dimensions just in case. Just in case. There were no dimensions given, so I will just put units to make the thing look nice. Units. Did I put my dimensions here? I did. One more question, please. One more for the road. Last one. So 2 variables. What's that noise? Or the bin? 2 variables, P and Q, are related by the following. Hey, look, we get an X something. Wait, nice. Dead, my battery dead. All right. Every time I say that, my pen I'm talking about. Like zoom in on the pen. This pen holding it down for you right now. The official Apple pen not working. And I have a generic pen that kind of doing it for you right now. So, all right, let's go to the question. So 2p is equal to the square root of q. Determine the value of p when q is equal to 9. What? Oh, easy thing, right, easy thing. was so easy, it kind of fazed me out there. But 2p is equal to the square root of 9 when q is equal to 9. 2p, that's not the right p. 2p is equal to the square root of 9. Why my q and my p looking the same way, boy? Okay, so 2p is equal to the square root of q. So when q is equal to 9, 2p is equal to the square root of 9, which is technically plus or minus 3. So 2p is equal to plus or minus 3. So p is equal to 3 over 2, or p is equal to negative 3 over 2. When you get the square root, it could either be positive or negative. Now, usually, people make a big thing out of this, right? Like if you don't put this, you're supposed to lose a mark. But usually in CXC, and I think I saw this in the syllabus, when you have the square root symbol, you assume positive unless stated. So, and when they want you to assume positive or negative, they'll usually do this, plus or minus. So, yeah, there's a little caveat there. But if you're feeling the heebie-jeebies, and I would, put in the negative as well. Make Q the subject of the formula. Yes, my pleasure, my pleasure. I can do that for you. So, B, make Q, make Q, right? So 2p is equal to square root of q. To get rid of the square root, we want to square both sides, and we'll end up with a nice 4p squared, because 2p by 2p is 4p squared. And when you square a square root, you just end up with, it's like you cancel it off. It's like the square root, and then you square the square root, and you unclose the square root there, so you just stand up there. Exposed, q, at the end there, max. Let me do the next part. So Molly walked for X minutes. Sam walked 10 minutes less than Molly. Hey, I could fill line in one time. 10 less than X. And Claire walked twice as long as Molly did. Hey, I could fill line one time. Twice as X. Right expression in terms of X for the number of minutes. I done had a holiday, X minus 10 and 2X. And the product of Sam's walking time and Claire's walking time is the same as the square of Molly's walking time. Jeez and ages. We need a new page. We need a new page. All right, so let me see. Next page. Last question. Last question for real this time, for real. They are trying to get the question to open up, but they don't want to. Okay. So just to bring it back, this man, Sam, was X plus 10. And Clay was 2X. Other student named Clay. So 2X from St. Lucia. 2X. So Clay, if you're watching, hello. X plus 10, 2X. So write expressions in terms of that. We collect with 2 marks. So let me take this one step by step. The product of Sam's walking time. So X plus 10 squared. And Claire's walking time. What we're seeing by is the product of Sam's walking time and Claire's walking time. So I just need to multiply the two. Product mean multiply. So the product of this and this, Sam and Claire. We going good so far? I feel like we're going good so far. The product of Sam and Claire. Sam and Claire. Is the same as, and when you say is the same as, what does that mean? Is the same as the square of Molly's walking time. So you have to take Molly walking time. Who is Molly again? Molly is just the X, and square that up. Nice, nice it is. Use this information. Oh, there's a show that question. We love them show that questions because you can work it out and see if you get your answer. Because they give you the answer. You just need to match it up now. Boy. So yeah, we could do that for them. We could do that. So this is distribution. So this is really 2x squared plus 10 by 2x is 20x equal to x squared. Bring across that x squared to meet your friend. So it's really 2x squared minus x squared plus 20x is equal to 0. So at the end of the day, this is just x squared. Hold on, we're at negative 20. Only I make a mistake. They was probably telling me that in the chat. We look at people telling me that, Kai, Jason. I nearly make a mistake in it. Well, I make a mistake. Let me be fair to myself. But you see, I had the negative 10 on the previous slide. If we go back to the previous slide, we see the negative 10 there. So I just when I was bringing it across, I forget to put negative. My bad. That's why I like them show that questions for, because if by chance you had make that mistake in the exam, when you reach down there, you're like, where that negative come out from? And boom, you realize it's supposed to be negative 20x. So you could go back and fix the mistake. Love in the house. So it's negative 20x, and we good to go there. Boom. And given that x must be a number that's greater than 0, find the number of minutes money walk. So we just need to go ahead and solve this now. Now, when you see a quadratic like this, missing the c term, those quadratics are extremely easy to solve. You just factorize all the x, and either that one is 0, the next one is 0. And they're saying x must be greater than 0, so it's not the 0. So factorize all the x, I'll get x into x minus 20 equals 0. So it's either x is equal to 0, this one, which is not valid, because since they just tell me x must be greater than 0, can't be equal to 0. Or x minus 20 is equal to 0. So x is equal to 20. What is this? It's time, 20 minutes. 20 minutes. And just like that, we rack up 5 algebra questions, just like that, boy. So, what today is Tuesday. Tomorrow we're supposed to do the Student Hub Live. Tomorrow I want to do some geometry, but I'm starting late because I have something to do lunchtime. So we start about 2 o'clock, 3 o'clock. So Student Hub Live is 6. And then on Tuesday, let me see if we could do some maths and our next subject too. So maybe I'll do something in the morning. We real studying. Well, I real studying. I don't know about you. You're supposed to be putting in them extra hours. So love and blessings, people. Hold it down. Good to see all of you all here. Press like on the video. Tell your neighbor, tell your friend. Come and study with me lunchtime. Now we do a little extra work. Or they could work it along with me. You see, I'm working at a nice pace. A huge volume of students, the fast ones and the, those who treading along at a slower pace, or they could keep up. Love and blessings. Hold it on. Geometry tomorrow. That's question 3. Take care.